Well, hello everybody and welcome to Qnetic's H1 2023 Investors webinar. Thank you very much for joining us and giving up your time today to speak to us wherever you're calling in from. So good morning, good evening or good night, depending on where that is. So just switching on their cameras there, we have Matthias, Malcolm and Loic. So they'll say hello in just a second. So we're going to spend about an hour, and the purpose of today's call is to really give you an update on all the things that have been going on at Qnetic since we first started fundraising at the beginning of the year. So it's a summary of all those things, an opportunity to understand that a bit more deeply. So those who don't know, my name's Mike Pratt. I am one of the co-founders and the CEO of Qnetic, and I'll get us started. But quickly, maybe Loic, then Malcolm, then Matthias could just say hello and who you are in a couple of sentences.
Sure. Welcome everyone. My name is Loic Bastard. I'm the CTO of Qnetic, and I'm very happy to have you here.
Hi everybody. My name is Malcolm Matthews, and I'm the CFO of Qnetic. Good to see all of you here. Thanks.
Matthias Mier joined Qnetic early last year, CEO of Qnetic, and I'm also happy to see you.
Okay, so without further ado, we'll move on to the first topic and the first achievement, which is all about fundraising. So, Malcolm.
Yes, so I'm sure all of you are interested on where we are on our fundraising campaign. The four of us, the core team, had invested just under 200,000 in December 2022, and that's what we've been using primarily for our operations to date. Much of what we've been using. The WeFunder campaign has raised just under 900,000 to date, with a little over a week to go. So a combination between us and WeFunder, we're just over $1 million in funding received to date. Meanwhile, we've also been having a couple of conversations with venture capital firms. One from the US, a hard tech venture capital firm that's interested in filling the gap between whatever we raise on WeFunder and what we require to get us to the next round of funding. And they have also expressed interest in providing funding in the next seed round as well. We have also been talking to another Shanghai-based venture capital firm that has expressed similar interest as well, and most recently another investor from Singapore/Australia that has expressed some interest as well. So as you can see, we've been doing well on the fundraising round and able to get into operations. With funding, obviously, we are able to get into full hiring mode. As many of you know, early on in the startup phase, much of the work is done by the founders and the core team, and then with as much as we can afford with part-time and other individuals, which is what we've been doing. But we have, over the last 60 days, started the hiring process to get in a first group of full-time employees. If you look down there on the bottom of the slide, you will see Joyce, who has actually been helping us on much of the marketing and PR activity, most of which you may have seen if you've been following us along either on LinkedIn or through any other of the social media platforms. We have Rain, who is expected to join us middle of July, and he will be coming in as a structural engineer, and Jiahui Zhu, who is a design engineer, who is also expected to join us in the middle of July as well. In addition, we are completing the process on a business planning director, and we're also still in the hiring process for an additional mechanical engineer. So as you can see, with all of the funding coming into place, we have started a hiring process and getting to work on our first prototype. And this should be sufficient for the coming design and development stage that for the next 6-9 months or so.
Yeah, so I will take over on this one. So this is kind of our first achievement in terms of prototype, because we've been able to build 1/10 scale of the Qnetic. So the purpose of this model or prototype is mostly to explain and demonstrate how our flywheel system is working. But it's more than that. It has been allowing us also to create something that is really working, and also validating some of the simulation we have been doing on the permanent magnet, for example, because this system and this rotor is fully levitated with magnetic forces. And yeah, so it's fully functional, which means it's charging from the mains. It's storing the energy with the kinetic energy on the rotor while spinning, and then we can discharge this energy and to light up some bulbs. And so it's fully functional and very, very happy about it.
Yeah, that prototype is just the first on a series of stepping stones to get us to the full-scale product into production. The investment funds that you guys have invested in Qnetic are directly funding these prototypes. So what's coming up in the next 6 to 9 months is this 25% scale prototype. So this will be a simplified version of Qnetic and built at a scale that enables us to do that quickly and cheaply, and does 2 key things: verifies the key engineering risks, and also enables us to build something that convinces investors and customers to support the company ongoing. Now, the next stage prototype, Pulsar, that we call Pulsar, is a large-scale prototype, and it is the full Qnetic design, although shrunk down to about 60% of the scale. So the reason for doing that is really to go faster to reach the point of large-scale prototypes in the real world and operating and making revenue. It would be very risky to jump straight from a small-scale prototype up to the full-scale Qnetic, and also would take quite a lot of time and money. So the Pulsar scale prototype solves that problem. And then following on from that, we have the Qnetic full-scale prototype. So all of the key risks within Qnetic are solved by Pulsar before we get to this full scale. So those are the key prototype stages, and hopefully you can see the logic in going from 10% scale to 25% scale, and then to the full Qnetic design, although smaller, so it's cheaper and quicker, and then to the full scale product. So that's the prototypes. What I want to also describe is how that looks in terms of the stages of the company and where that is. Now, Qnetic is always intended to be a global enterprise, and that's because we are attempting to solve for a global problem, which is global warming. Now, the company was born in Shanghai, but actually the plan is always to be a global enterprise. So we need to, the plan is to sort of transition out of China quite early. So this stage of the project here, Antares, which is the 10% scale prototype, and Vega, the 25% scale prototype, that's happening now here, happening in Shanghai. And then after that, the location of the prototypes will be outside of China, most likely in Europe, but could also be the USA. Once the Pulsar product is fully developed and we're putting those into test sites, they will be around the world, starting in Europe, and then the US, and then potentially Asia. So that's just to make it clear that as an enterprise, yes, we're born in China, but the product is a global product, and the center of gravity of the company is going to move outside of China towards the beginning of next year.
On the intellectual property, well, I want to say that we are attacking the problem of bulk energy storage with flywheel technology. Flywheel are not new. It's not a new way to store energy. It's quite old and well known, actually. But the classical flywheels are storing energy for a specific application, which is frequency regulation, which requires the system to have a very high power output and a very small capacity, a very small rotor. We are trying to design, our system is designed actually for bulk storage, to store for a long duration storage, which is 4 to 12 hours duration. And we are storing a very large capacity, so a very big rotor spinning at very high velocity. It is a completely different engineering problem to solve compared to the classical flywheel. And that opens the opportunity for us to really reinvent and define new ways to answer the problems that we have that are very specific to our architecture. So, for example, the bearing, we have filed a patent for the bearings that is a very innovative way of guiding the system. We will talk a little bit more about that on the next slide. But the rotor itself, it's a very specific IP we're going to develop, and we are currently working on the patent on the rotor because we have a very specific design that is very lightweight, that can achieve very high speed. If we want to store kinetic energy, we want to go fast. So that's what this rotor is achieving. We have also a patent project to file patents around the architecture and also around the way we are balancing the rotor. And the last but not least, we have planned to patent an innovative way to stop the system in case of failure. So several layers actually of safety procedures around the flywheel. And all of those 4 patents will be filed in 2023. So this is a zoom view of the bearing application we made this year already. So it has been filed in April this year. So it's a bearing system for radially constraining a rotor of a kinetic energy storage machines. That's the title. So what we are doing here is eliminating any high magnitude vibration. Actually, we are avoiding resonances. I cannot tell you too much about it because it's a secret. You would understand. But basically what it does, it allows the system to spin with very low losses. It allows the system to spin during operation. The system is spinning without any contact with any mechanical contact. It's suspended and guided fully magnetically. And this system that we design is unique to Qnetic today.
So I'm sure many of you are curious about the progress on our structure. And as Mike had mentioned, we intend to be a global company, and the structure was planned from that perspective. So while we were born in China, you can see there the Qnetic technology company that's based in China. That entity is owned by a Singapore entity, and then the topco for the company is in the US. This is where the founders, the core team, as well as all of the investment individuals that are coming in, both from a WeFunder perspective and any potential venture capital, this is where they will own shares, is in the Qnetic Corp at the top core level. And what we are happy to say is that we have just started the process of incorporating an entity in Germany, in Hamburg, the metropolitan area of Hamburg, just about an hour north of there. And Matthias will provide you a little bit more information about that in the coming slides.
I'm very happy that we can announce the incorporation of the Qnetic GmbH. The Qnetic GmbH is the European entity located, as Malcolm mentioned, in the northern part of Germany. Although I'm the general manager of the Qnetic GmbH, the company is managed by the global management team you can see here on the screens. The key rationale behind the incorporation of the Qnetic GmbH is to prepare and start real-life operational business. And that will begin with the prototype site preparation, the installation and testing. We are going to develop, especially for the minimum viable product, so the smaller product, we are starting with supply chain and manufacturing. We will be in charge to develop European customer projects, markets. And last but not least, also one reason that we are located in the northern part of Germany, we will have access and manage German and European grants, public grants. Yeah, we are located in the Hamburg metropolitan region in the northern part of Germany. We experienced already during the incorporation process very strong governmental engagement for the Qnetic GmbH. Also very clear understanding how we are going to be supported. Very short term, we will have access to some seed grants and some subsidies for salaries. But medium target is beyond €500,000 grants for R&D and especially also for all our prototype activities. Long term, even we will get support from the local government to get access to European grants. From my point of view, we are a very small company with limited resources. So our strategy is to leverage a strategic partner who are sharing our vision. And one of them I would like to introduce is Harco Carbon. It's a family-owned company who are sharing our vision, far beyond finally earning a lot of money. They have high expertise in composites, especially filament wound structures, experience with machinery and manufacturing. They can support us already with a smaller rotor, but finally also with the full-size diameters, for example. They are going to deliver rotors for the prototype and at least for the first pilot projects. And they have also strong capabilities and special software for design and manufacturing optimization we are sharing and we are going to utilize. Yeah, we have a second strategic partner already more or less on board. This is Recase GmbH. Recase strongly supported us already in finding and developing the prototype site in the northern part of Germany. Also helped us to get all the necessary permits. Recase is very experienced in, let's say, at least European project development, project engineering, competent in electrical integration of wind turbines, solar systems, but also storage. They have the infrastructure to manage installation, commissioning, operation for us and probably far beyond the prototype. And again, last but not least, they will help us and support us to get access to grants, to public funding. What may be worth to mention is that we are also going to share the office building as well as some infrastructure. So Qnetic GmbH will have a relatively easy start because we don't need to build up all the company infrastructure, but also utilize a part of the Recase capabilities here.
So yeah, we have other key suppliers that we are leveraging currently. You know, our system, as Matthias said, we are a small team, so we need to leverage existing expertise. And our system, luckily for us, is designed with where we can source the main parts from a specialist. For example, the active magnetic bearing, we plan to source them from Waukesha, a US company that is specialized in designing specific active magnetic bearing. We have also, as you know, a permanent magnet bearing to be able to lift the rotor and take the mass of the rotor, the vertical load. And for that, we need very specific magnets, very high quality magnets, and we need to be able to build those magnets specifically in the shape we need. And for that, we have a partnership with Ningbo Permanent Magnets in China. We also are developing a partnership with The Switch. It's a European company that is providing high speed and high performance generator. And they have very disruptive and innovative way of designing the system, so we quite like it. And last but not least, we are developing relationship with Green Wind Engineering in Germany. They are specialized in rotor balancing and are keen to transfer their knowledge to us.
So in addition to those suppliers, we have strategic partnerships with several other organizations, the first of which is MIT. We're very fortunate that one of our advisor board members is an instructor at MIT and Harvard and is well connected to the ecosystem around there. And we've already started a project with them to help us optimize the composites that are so crucial for making the best possible rotor that we can. So that will involve experimenting with different carbon composites, different resins and different additives to get the very best strength per dollar, if you like. Now, long term, we're going to be continuing working with them to develop our own material for the rotor. Now, this will be a material that is not necessarily a composite. It could be a mono material and also fully recyclable. But to get there, it requires a certain level of R&D. So we're engaging with MIT on that to try and solve some of the key issues that will enable that material that I'm not going to mention to be utilizable for our application, which will be a big advantage because, as you may know from some of the information that we've been putting out, it really is about having a nice lightweight material that is low cost and high strength. So carbon fiber is not the only material out there for that. There are other options, but each material has its pros and cons. And there's some work to be done to enable this next generation material. So the key thing to understand here is there's near-term improvements that can be made to the materials that we're using in the rotor, but long term we're planting seeds for the next generation of product that could be available in years to come. The second one is Berger Wind Park Janeby. I won't say too much because Matthias will mention a few things about this, but essentially they're a partner that will enable us to be testing our first range of large-scale prototypes, the MVP. And the third one is Rouse. This is our patent partner. It's very important that a company like us partners with a high-quality patent attorney for a long-term relationship where the agents or attorneys who are writing patents for Qnetic get very familiar with the product and very familiar with the technology such that they can be very efficient with writing the patents first of all, but also give us the best advice as we go forward. So we partnered with Rouse on a long-term basis. And as Loic mentioned, we've already filed our first patent with them, and the next 3 patents are lined up over the coming several months. So those are our strategic partners.
Yeah, once more back to Berger Wind Park Janeby. It is the largest wind turbine test site up to now, but they are developing a lot of other activities, especially around storage equipment and testing. For example, also in close cooperation with Vestas. The Qnetic flywheel will be coupled with wind energy, will have access to energy trading via Janeby, and we will be able to demonstrate already not only the technology in terms of prototype testing, but we will try to demonstrate a real business case already. And again, last but not least, our friends in Janeby, they will also get access to grants. So we expect that we are already able to sell the prototype under very special condition, but have additional funding for the prototype cost.
Yeah, similarly, we are working in France with Eurocom, which is a graduate school and research center in digital science in the south of France, close to Nice. And they agreed to install a system, a pilot test system to couple with their solar farm, and also support us to get access to grants for this pilot project. So that will come probably early 2025. That's what we are discussing with them. I'm actually in France right now, and I will be signing the letter of intention tomorrow with them. So we're going to announce it soon.
Berger Wind Park Janeby and Eurocom are essentially our first customers for our product. And we're looking for more pilot test sites like this, not just in Europe, but also North America and around the world. And over the coming year or so, we'll develop those relationships and develop the planning to enable us to install our MVP product in those locations. And really that will do several things. Obviously validating the product and the technology, of course, but generating demand. Once the product is operating in real world, local to where our customers are, then we believe that is the biggest lever to pull to generate demand for the product. So that's very important. Now, one other thing that's really important when talking about customers is how much money can they make if they invest in a Qnetic product. So we did a study to try to establish that. Now, I have to say this is a simplified study because it doesn't take into account the full range of revenue streams that you could make from a Qnetic flywheel energy storage system, but it does make a direct comparison between lithium-ion batteries and Qnetic flywheel energy storage for the same type of use. So this was done by researchers at Imperial College London, whose specialism is the topic monetization of energy storage. And in fact, they are co-authors of a book that is coming out, I think, next month, titled Monetization of Energy Storage. They really are world experts on this topic. So we asked them to look into this, and can you tell us how much money could a Qnetic product make if a customer invested in it? So we modeled that based on just energy arbitrage. So in reality, if you own an energy storage facility, you won't just be doing energy arbitrage, which is essentially where you buy energy at low prices and sell it at high prices. You'd also be doing other things such as frequency regulation and peaking capacity response. So when you have multiple ways of making money from the same energy storage asset, this is called revenue stacking. So we just chose energy arbitrage as the only revenue source for this model, and we chose a 4-hour discharge duration, which is typical for lithium-ion batteries, and an 85% round-trip efficiency, which is normal for lithium-ion batteries and is also what we hope to exceed with Qnetic. So based on that, actually it means that the profitability or the effectiveness of the system for both lithium-ion and for Qnetic is the same. But if you actually run the full calculation to look at how much money you can make from the system, then Qnetic is twice as profitable as a lithium-ion system. And the reason is because lithium-ion systems degrade, which means that you have to keep reinvesting in your lithium-ion battery to make up for degradation of capacity. You either do that you either induce costs because your capacity keeps going down over time, or you have to keep replenishing the cells, and therefore you introduce new capital expense throughout the lifetime of the asset. Now, if you did add in other revenue streams such as frequency regulation and peak capacity, then your internal rate of return would improve and your payback period would shorten. But if you just take that one revenue stream and compare lithium-ion to Qnetic, then you'll make your money back twice as quickly with Qnetic.
So from an investment perspective, I am sure that many of you are interested in the exit strategy or what the potential exit strategy might be for you. As anybody that would invest in a startup, the Qnetic investment is really a long-term investment for anyone. It's meant to provide a better solution for the climate issues that the planet has, and we intend for this technology to be disruptive and really change the way people are looking at energy storage in the market. And it will potentially be a very profitable entity. That is our intent, and it will come over time. So there are possibly several exit scenarios for an investor that comes into Qnetic. One possibility is that the company gets bought. There may be a big industrial or an investment firm that decides to buy us as we go through the process. Another possibility is that when the Series A round financing comes around, which we expect to be in the early part of 2025, somewhere before June of 2025, there may be an opportunity for current shareholders that invest through WeFunder to be able to sell or part or all of their shares to somebody else who may take up that investment at that particular time. And if regulation allows, and if by then there is an avenue to be able to do so, we fully intend for us to be able to trade shares in an open internal market after that Series A investment is successful. And obviously, the one that most people hope for is that we're able to go IPO at some point here in the future, and then it's a whole different story on the return on investment. And this is just to paint that there are different ways on an exit strategy for an investor. It's going to depend obviously on a whole lot of variables, depending on venture capital, obviously the success of the prototypes, but it gives you a little bit of insights into what those potentials might be.
Okay, so we've covered all of the main topics that we wanted to in our slides here. There have been some questions in the chat, which I think most have been answered as we've been going along. But I can see there's a couple more here that perhaps we could handle.
Question from Thomas Butler about the efficiency. Do the permanent magnet lose efficiency over time in any way? A permanent magnet is a very stable system. It doesn't lose its magnetic power unless it gets eaten, or so its temperature gets over a certain threshold where it demagnetizes. So it's very important to keep control of the temperature in the system and make sure we stay below a certain threshold.
Yeah, I wanted to answer this question about patents. There was two questions here. One about, is there an IP risk of filing in China, and what jurisdictions will you file your patents in the national phase? So we shared some concerns around filing in China, but the solution to that, which is advised by Rouse, which is quite smart, is to rather than file a Chinese patent and then go to the PCT stage, it's filed as a PCT right from the beginning in English. So it is processed by the Chinese Patent Office, but it's not a Chinese patent except in China. It's going to be straight to the international system. So then when we go to the national stage, we'll be filing in enough jurisdictions to cover the world. So we won't be doing every country, of course. What you typically do is the major economies in the major territories. So for example, you do US, you'd have a European patent which covers all of the sort of European territories, and then China and maybe a few other kind of key Asian territories. And that's essentially how you do that.
The Chinese patent for the Chinese region is owned by the Qnetic entity in China. And for the rest of the world, the patent is owned by Qnetic Corp in US. That's how it's structured now. So we can separate the two things if we need to quite easily. So there were a question from Thomas again. Any plan to market the 60% scale as another solution while developing full size? Well, absolutely. That's what we're going to do actually. During the 2025-2026, we're going to develop the Qnetic full size, but in the meantime, we're going to produce this MVP. And this MVP, we talk about pilot site, but really we're going to try in this period of time to manufacture around 200 units that should be sold or leased to different customers. And we believe this MVP could be a very good solution for C&I, so commercial and industrial customers.
Okay, so there's a question, what other companies are developing bulk flywheel storage solutions? Is it a competitive environment? Frankly, no, it's not a very competitive environment right now. We don't see, I would say, any other companies who are developing flywheel energy storage at the kind of bulk scale that Qnetic is. We can see a number of other companies, both startups and established companies, who are developing, I would say, small flywheel energy storage systems and for niche applications, some of which are grid attached, or it could be sort of isolated power systems such as car fast charging. So car fast charging is one application. We see energy recovery for locomotives is another application. So there's several companies doing that, but what we don't really see are any other companies doing bulk storage of energy at grid scale to support renewables. So we think we really have first mover advantage in this area. What we have seen that's quite encouraging is there's another company who's developing a flywheel system that has some similarities to the approach that we're taking. Now that's quite interesting for two reasons. First of all, it means that there's some other people who have drawn some similar conclusions to us about the best way to approach the design of a flywheel energy storage system. And that's useful because it kind of validates our approach. But the second thing is that they've also taken a sort of niche market, which is fast charging of vehicles, but they have been given grant funding by the US Department of Energy. So that means that they have gone through the due diligence process with the DOE and received funding. So that's quite encouraging. So we do see that, but we don't. They're still a relatively small scale, maybe 2% of the capacity of Qnetic.
Would a flywheel connect directly to rotor energy of a wind turbine, bypassing an electrical conversion between the two? Well, not really. The reason why is if you take the rotor of a wind turbine, it's like a gigantic flywheel actually, with a tremendous inertia. And it contains actually a lot of kinetic energy in itself. Actually, the wind turbine is already kind of a flywheel, and they are using it to do control of frequency and frequency regulation. When they are putting power in the grid from the wind turbine, they are using this property of massive inertia to control the power. But but it would not work with our energy storage. I think we need to really our system is complementary to the wind turbine, and it works only if we separate them into systems.
Is the plan for the product to be grid connected in the future or strictly behind the meter? Actually, the product is always been intended to be grid connected. As Loic mentioned, we also want the MVP to be suitable for commercial and industrial customers, so they have that on site. But really the purpose of the product is to decarbonize the grid. So therefore the intention for Qnetic, and one of the reasons why it's developed to be this large scale system, is because it's intended to be connected to the grid. And there's another question here. Any thoughts on developing a constrained product that could be deployed in resource constrained settings, picturing something that requires less high-tech materials but is improved from simple flywheel designs? Actually, this may be a little bit counterintuitive, but by using the high-tech materials, we're able to get the cost down. It's not a case of, okay, we can use simple materials and that's going to be a cheaper product that's more mass market. Actually, that's not really going to be the case. If you wanted to make the product using steel, for example, common, relatively low-cost material, you would not be able to make a high-capacity solution for low cost in the way that Qnetic is. So for comparison, our system, the rotor itself, the part that stores the energy, is going to be about 17 tons. And if you were to try to store the same energy using steel, it would be more than 200 tons, which makes it not really feasible as a product. So yeah, it might seem like it should make sense to use simple materials like steel or concrete to make the rotor, but you would never be able to achieve a low-cost, high-performance system in the way that Qnetic is.
Actually, it works for small system. If you are designing a system that is aiming for residential storage or low-capacity storage, like Energy Straw is doing in France using concrete, or Amber Qnetic, if I can say, using steel. Yeah, that would make sense. It would be expensive per kilowatt hour, but yeah. But if you want to answer the bulk storage in a grid scale storage, then you really need to go into higher, bigger dimension and the higher energy density as well. So yeah. That's why we ended up using high-tech material and composite material.
Okay, well, thank you very much for the questions as we've been going along. I think they're quite insightful. Now, we intend to be doing this every quarter going forwards. having some kind of update like this. Partly we'll send out information to everyone who's already invested. Of course, we're sending out information frequently right now, but after the campaign is finished at the end of the month, just 9 days time, then information will be still regular, but much less frequent. So it'll be bothering you a bit less, but perhaps with a bit more information. And we'll like to have a quarterly update just like this to give everyone an update and catch up on your questions. So this is the first of those. So very happy to be able to do that for the first time and look forward to seeing everybody again next time. Okay, so suffice to say, thanks so much for attending. Maybe the rest of the team want to say thank you and farewell.
Yeah, thank you very much for for supporting us and believing in the mission.
Thanks, everyone. Appreciate you taking the time.
Don't forget to make your network aware that the VFunder campaign of Qnetic only works another 9 days.
That's true.
Have a nice day, have a nice evening.
Yeah, I'll just re-emphasize that point. Mette is absolutely right. There's only 9 days left. There's still time for you to up your investment if you so wish, and encourage others to do the same. We've really got a very short window now of a chance to invest. So yeah, appreciate further support. Thank you very much.